Hey, welcome back. This is Math 1530, Test 4 review. Test 4 will be in my math lab. Of course, it will be proctored by me in WebEx. So you have to log in the WebEx, and then I'll give you the password for the test, and then you'll take the test in my math lab. Did I say WebAssign? I meant my math lab, whatever I said. Okay, so it's like our second test, the way we took our second test. Okay, so you want to take a look at some of the problem types that are on the test. The test, I think, is actually 25 problems long. So I took about 4 to 5 problems from each section. For 7.1, that was systems equations, and I'll be asking for problems like 5 to 41 odd. Okay. We taught you 2 techniques in this section. We taught you the addition method and the substitution method. You can use either method on the test. It won't matter. They won't know. I won't know. Because ultimately they want is the answer, right? So anyways, I'll do one of each, depending on which method you like. I would prefer you learn both methods, right? Because eventually we're going to have to work with matrices in Chapter 8, and that kind of is like an addition method plus substitution method on top of it. So I think it's in your best interest to learn both ways. Okay, I said my piece. Okay, so the second equation, I'm going to solve that guy for y. Okay, so I'm going to move the y to the other side, and I'll have 3x minus 11. Then I'll substitute that expression into the unused equation, this guy here. Okay. So I'll have 2x plus 5 times 3x minus 11 equals negative 4. Then you have 2x plus 15x minus 55 equals minus 4. Combine like terms, 17x. Move the 55 the other side, you get 51. Divide both sides by 17. I think that will give you 3. Okay, and then you're going to back substitute into any equation that has both an x and y. In particular, I like to use this equation because it's already solved for y. Okay, you may not have the experience to do that, to pull it off, but if you do, I mean, it's the way to go. So anyways, you can use this equation. You can use this equation. It doesn't matter, but the red one is probably the best. So y equals 3 times 3 minus 11. So I have 9 minus 11, which of course is just negative 2. And our final answer, 3, negative 2. Okay, so that's the substitution method. We also gave you the addition method, so let's look at one of those characters, something similar to that. Okay, so here's 27. 3x minus 4y equals 11. And 2x plus 3y equals negative 4. Okay, so we're looking for column-wise cancellations, and if there isn't one, you have to multiply either one or both equation by a non-zero constant. Okay, so I'm going to multiply the first one by, I guess, negative 2, and the second one by 3. That'll do it. Right, that'll get rid of the x. So I have negative 6x plus 8y equals negative 22. And the other guy, multiplying by 3, so I have 6x plus 9y equals negative 12. Okay, that'll give me the 6's go away, the x's go away, and I have 17y equals negative 34. Divide by 17, and we have our first part of our solution. Okay, y is negative 2. And then just back substitute, I'll take the first equation I see, 3x minus 4 times negative 2 is 11. So I'll have 3x plus 8 is 11. So I have 3x equals 3. And then, of course, you get x is 1. So in the end, our solution 1 comma negative 2. And so on and so forth. So, I mean, they have other problems that are a little more complicated, like when you have fractions, or maybe the order is kind of out of whack. We could take a look at one more. So let's try 39. So here's some scary fractions in here. X over 4 minus y over 4 equals negative 1. And then x plus 4y equals negative 9. Okay. So I hate fractions so much. You know what I'm going to do? I'm going to get rid of the fractions in that first equation just by multiplying by 4. Okay. So I end up with x minus y equals negative 4. In my other equation, x plus 4y equals negative 9. You can do that. That's legal. Okay. You can multiply by any non-zero constant. and it doesn't change anything. It's still the same line. All right, I'm going to do a cancellation because it looks like the x's are real easy to get rid of. So I'm going to multiply my first equation by -1. So I'll have negative x plus y is 4. And so I have x plus 4y equals -9 on the other guy. And then if we add these guys up, we'll have 5y equals, looks like, I think that's a 9, right? So -5, so y equals -1. And then you can pick any equation you want and just plot that. I'm going to pick this guy because that seems real simple. X minus -1 equals -4. So x plus 1 is -4. And x is -5. So my solution this time, -5, -1. I was hoping to get an uglier solution out of it, but no such luck. Kind of a boring problem there. Be aware that there are the infinite solution cases or the no solution cases floating about. So for example, this guy, y equals 3x minus 5, and then 21x minus 35 equals 7y. Okay. I'm going to do a substitution method because that first equation is already solved. So I'm just going to go like y equals 3x minus 5. That's my guy. I'm going to plot that guy into this guy. Okay, so I get 21x minus 35 equals 7 times 3x minus 5. So I get 21x. You try to solve for x, right? So distributing 21x. I'm not overthinking. I mean, obviously something's weird's going on because I got the same thing on both sides. Anyway, so you just go work as usual, business as usual. Move the 21x over. I get -35 equals, that's a true statement. Okay. And what did that mean for us? That meant infinite solutions. Okay. And the software, I think they give you a choice, like, you know, this, or this. So an ordered pair, or no solutions, or infinite solutions. For the answer in infinite solutions, usually they'll give you, I think they give it to you, the set notation. It's a set of all x comma y's. If they don't, this is how you do it. It's a set of all x comma y's such that, and then you just pick off one of these equations and plop it into the set. Okay, such that y equals 3x minus 5. Okay. Turns out both of those equations are exactly the same. If you were to multiply this guy by 1/7, you would get 3x minus 5 equals y. See, those things are exactly the same. Okay, so the solutions are just all the points that lie on that line, and that's why your set notation looks that way. It's a set of all x comma y's such that y equals 3x minus 5. That's what that thing means. Okay. Okie dokie. 7.2 then is just this idea on steroids. We'll be revisiting this in chapter 8 with matrices. So eventually we won't use the variables, we'll just use their coefficients. But in the meantime, here's 7.2, and we're looking at problems like 5 to 15 odd. Okay, and I think I put maybe 2 of these on the test. I didn't get carried away with these because they're a bit longer and they're easy to screw up. So anyways, let's take a look at 1 or 2 of these. Let's take a look at, I don't know. Should probably do one I already have written out. Let's try number 7, I guess. Okay, so 4x minus y plus 2z equals 11. And then x plus 2y minus z equals -1. And then 2x plus 2y minus 3z equals -1. I'm going to just make sure I copied it correctly, right? Because that's half the battle. Okay, we're good. So I need to pick a variable to eliminate. I'm going to pick x, so get rid of x. Okay, so first I'm going to use the first 2 equations, and I can get rid of x by multiplying the second one by -4, right? So I go and multiply the second guy by -4. And what do you get? Well, you get 4x minus y plus 2z equals 11. And then I have -4. Let's make that look a little nicer. -4x minus 8y plus 4z equals 4. Okay, and then I add these up column-wise, negative 9y plus 6z equals 15. Okay, now I'm going to use the second two equations, and I can get rid of x by multiplying the first one by negative 2. Okay, so multiply that first guy by negative 2. And I'll end up with negative 2x minus 4y plus 2z equals 2. And the other equation unchanged, 2x plus 2y minus 3z is negative 1. Okay, so that'd be 0, negative 2y minus z equals 1. And there's my system. Okay, so I have now a new system, and I have to solve this new system, which is in variables y and z. Okay, so I have negative 9y plus 6z equals 15. And I could get rid of that z variable by multiplying the second equation, which is sitting right here to the right, by what? Well, by 6, right? Multiply by 6. And I have negative 12y minus 6z equals 6. And then I can add everything up. Negative 21y equals 21. Okay, and then I'll have y is negative 1. Finally, you just do a bunch of back subbing, right? So back subbing. First, I'll pick any equation that has the x and the y and the z in it. So I'll just pick the first one I see, negative 9y plus 6. Oops, I'm supposed to be putting in y, right? So negative 9 times negative 1 plus 6z equals 15. So negative and negative is positive, 9 plus 6z equals 15. And then 6z will equal, I guess, 6, and so z will be 1. Smush that in there, sorry. Then take any equation that has 3 variables in it and substitute in z and y. So we have 4x minus negative 1 plus 2 times 1 equals 11. And I just use this equation right here as all 3 variables. And so I have 4x plus 1 plus 2 equals 11. So 4x plus 3 equals 11. And then 4x, okay, I really have to smush this in here. I'm sorry, I'll scroll down a little. So then I have 4x equals 8, and then x equals 2. Okay, so our final solution, 2, negative 1, and then 1. Okay, okay, so these, you have to be careful when you do them. It takes a bit of accounting work. If you're good at these, you might want to go for being an accountant or something like that, or working in a bank. Right? It takes that kind of person. Some people really like to do that kind of stuff. It's sometimes life is just too intense. You'd rather just sit around with numbers all day long, and that's fine. Let's do another one. Let's try something like number 15. This was a little weird because it doesn't have all the variables. Right, so that first equation just has 2 variables. Then I have y minus z equals 1, and then 2x plus y plus 3z equals negative 21. Okay, I'm going to get rid of, I don't know, what do I want to do? I think I'm going to get rid of the y. Get rid of y and just get system in terms. Sometimes you have to sort of fly by the seat of your pants in math. Okay, you're going to have to kind of just guess. So I'm guessing I'm going to get rid of y. Okay, rid of y. So if I take the first equation and the third, okay, I can get rid of y that way. Okay. I may be doing too much work. I wonder if there's an easier way to do this. Wouldn't it be easier to just do substitution or something? We could try that in a second. Okay. So anyways, I'm going to get rid of y. So x plus y equals negative 4, and I can multiply this by a negative, right? So negative x minus y equals positive 4. And the other equation, 2x plus y plus 3z equals negative 21. Okay. So I have x and then plus 3z equals, and this is positive 4, so that would be negative 17. Hopefully I don't forget it's negative. Okay, the other 2 equations I can use then would be the second and third, right? And if I multiply the first by negative y, I'll cause a cancellation. So again, negative y plus, this time it's negative y plus z equals negative 1. And the other equation, 2x plus y plus 3z equals negative 21. Add those up, you get 2x plus 4z equals negative 23, really? Okay, either I made a mistake or the book is just being mean. So here I go. I'm going to form my new system, x plus 3z. Let's multiply it by negative 2, right? Let's just cut to the chase. So negative 2 times this first equation. So negative 2x minus 6z equals positive 34. And then we have 2x plus 4z equals negative 23. And then I can subtract or add column-wise, so negative 2z equals, it looks like 9, or 11. Ugh, seriously? No, there's no way. Oh, I see the error. Oh my gosh. Error. I mean, little things will do it to you, right? It's like, oh my gosh, really? And then that would be 12, and z, I think, would be negative 6. Sort of cheating a little bit, like in the way I look, yeah. Right, so if that happens to you, don't panic, okay? It may be easier just to skip these hard ones and go on to the other ones and then come back and do these, okay? It may just be a lot easier to not have to worry about it until the end. Anyways, there's one of the answers. Now we can start back subbing. Back sub. And so x plus 3 times negative 6 is negative 17. X minus 18 is negative 17. So x is equal to 1. And then plug in for y. Plug in, well, I could just use negative y plus z. I can just use this equation. You don't have to get carried away. Plus negative 6 is negative 1. So negative y is 5, so y is negative 5. Okay, so it looks like we got 1, negative 5, negative 6. Okay, are there any other ways to kind of do this? Well, we could do like a substitution thing. I don't know how far that would get you, but you can kind of maybe solve this for y, or solve it for x. So x is equal to negative y minus 4, and then I don't know, 2 times negative y minus 4. So I'm plugging it into the third equation now. Plus y plus 3z equals negative 21. So negative 2y minus 8 plus y plus 3z is negative 21. Negative y plus 3z equals, add 8, so that would be, so that'd be like 13 negative. And then I have two equations in terms of y's and z's. So that and this other guy. And then try to solve that as a system. You could straight up do that too. X equals negative 12, and you're getting x equals negative 6 right off the bat. And so going back to this equation, so negative 6 equals negative y minus 4, so y equals 2. And then finally, go back to this equation to get z. So y, or 2 minus z is 1, so bring the z over to the other side and subtract 1. So negative 6, I screwed that up somehow. What did I do? So negative 12. Is x negative 6? No, I guess that's where I screwed up. Y equals negative 21. Well, I don't want to spend 3 years trying to figure out what I did wrong, but I did something wrong. I'm just not saying it off the top of my head. I lost the 8. No, add the 8 over 8, 9, 10, 11. That's 13. Then borrow the y minus z. So the y's cancel. 2x. No, it's a 2z. Z, and then z is negative 6. Sorry. Yeah, and then that's right. So then I could go back to the y minus z. So y, that'll become plus 6 is 1. So y is negative 5. And then, I don't know, what do we need? X. So x equals negative y minus 4. X equals negative 5, which is 5, minus 4, which equals 1. So there's 100 ways to skin a cat. You know, that's what it comes down to here. And I gave you kind of a procedure for doing it in class in the video, but there are other methods, okay? And so long as you get the right answer, the computer's not going to care how. Well, you better not cheat, but you know the computer doesn't care how you got to the answer. Okay. Let's move on to 7.3. And in 7.3, I decided to be nice and only give you linear factor problems. So if you remember partial fractions, there's 4 types of problems: the linear factors, repeated linear factors, irreducible quadratics, and repeated irreducible quadratics. We're only going to do linear factor types. Okay, so linear factors, only, not even repeated. So no repeats. And so we're looking at problems like 9 to 15-ish. Okay, so let's look at 1 or 2 of those. For example, number 11, we have 3x plus 50 all over x minus 9 times x plus 2. Okay, so the first thing you got to do is set the guy up. Okay, let me log out. Nobody came to my office hours as usual. No, people usually come. I really got lucky today. I don't know what the heck happened. Sorry about that. Okay, so I need one fraction for each linear factor. And then in the numerator, all you have to do is put A, B, C, D, E, F, G, whatever. Then you're going to multiply everything to get rid of the fractions. So you'll multiply by the denominator that's on the left there, on both sides. So x minus 9 times x plus 2. Over here, also, x minus 9 times x plus 2. If you do something on one side, you have to do the same on the other. Those guys are gone. 3x plus 50 equals distribute. So we'll have the x minus 9s cancel in the first distribution, and I'll be left with x plus 2. The x plus 2 cancel, I'll be left with x minus 9. And so we have this situation. You could do equating coefficients, but it's easier to do a substitution method. Okay, so we want to create a cancellation. So you kind of look at this thing and solve for x. Okay, so x plus 2, set it equal to 0. So x is negative 2. And then we plug negative 2 into the entire equation. So you're going to have 3 times negative 2 plus 50 equals a times negative 2 plus 2 plus b times negative 2 minus 9. So what do we get? Negative 6 plus 50 is 44. A times negative 2 plus 2, that's a times 0 is 0. And then negative 11b. So b looks like it's negative 4. Okay, and what's the other number you have to pick? Well, it comes from here, so pick 9. That'll get rid of it. So this time, 3 times 9 plus 50 equals a times 9 plus 2 plus b times 9 minus 9, which would be 0. 27 plus 50 is 77. That'll equal 11 a's. Divide both sides by 11. And you get a is 7. So at the end, our partial fraction decomposition will be 7 all over, a was over x minus 9, plus negative 4 all over x plus 2. Okay, let's try another one. Let's try, I guess, number 13. Well, there's not too many to choose from now. 13, 7x minus 4 all over x squared minus x minus 12. Okay, so this one is different because you have to factor the denominator, right? So this will be equal to 7x minus 4 all over x, means x has to be plus minus, bigger number has to be negative. Okay, then we can set it up. And it's the same sort of game as before. So I'm going to multiply both sides by x plus 3, x minus 4. And we end up with 7x minus 4 equals, now I have to distribute. In the first distribution, the x plus 3's cancel, leaving you with a times x minus 4. The second distribution, the x minus 4's will cancel, leaving you with b times x plus 3. Okay. And again, we have to pick numbers that will cause cancellations. So I need to pick 4 to get rid of the a. So that'd be 7 times 4 minus 4 equals a times 4 minus 4 plus b times 4 plus 3. Please show work. Okay. Nothing more disappointing than when somebody shows a bunch of work that is wrong and somehow they magically get the answer. And I'm like, what? I don't know what to do. What happened here? Do I mark it wrong? Do I mark it right? No. Your work has to be correct and your answer has to follow from your work. So please, please, please don't do any magic shows for me on the test. Okay, anyways, 28 minus 4 equals a times 0 is 0. B times 7 is 7b. So I'll have 24 apparently equals 7b. And then I can divide both sides by 7. I'm getting a weird fraction here. Okay, the other guy, let's try negative 3. 7 times negative 3 minus 4 equals a times negative 3 minus 4 plus b times negative 3 plus 3. Okay, so negative 21 minus 4 equals negative 7a plus 0. Negative 25 equals negative 7a. And it looks like I get another weird fraction, 25 sevenths. Okay. Then write out your partial fraction decomposition. So it would be 25 sevenths all over, what was a's? X plus 3, right? Okay, x plus 3. And then plus the 24 sevenths all over whatever the b's denominator was, x minus 4. So usually on a test I'd let you write it like that, but I think software wants this answer. So I'll just include that for completeness, as they say. Okay, and that would be the answer you would type in, I guess. Okay, so there's going to be a mess of those for you to do on the test. Again, only linear factors, so none of that irreducible quadratic stuff or repeated factors, nothing like that. Okay, 7.4. So I'll be looking at now problems similar to, let me scroll over there, 1 to 27 odd. Okay, so I took a whole bunch of these and put them on the test. Let's look at problem number 3. Okay, so we have x plus y equals 2, and then y equals x squared minus 4x plus 4. Two methods, again, addition and substitution. You could use either method you want. The computer won't know, I won't know. Okay, so I'm going to use the substitution method. So first I'm going to work with this equation. Okay, so I like to avoid square roots, avoid fractions, stuff like that. Just keep it simple, stupid. And at the end, I always do like a spot check, right? Okay, so here we go. X plus y equals 2. I'll solve for y equals 2 minus x. Substitute that into the unused equation. So 2 minus x equals x squared minus 4x plus 4. Move everything and set it equal to 0. X squared minus 3x plus 2. Factor that guy. So I have x and x. It has to be minus minus. And it has to be 2, 1. And set each factor equal to 0. So x is 2 and x is 1. And then get the other coordinate. So when x is 2, y is 2 minus 2, which is 0. When x is 1, y is 2 minus 1, which is 1. Okay, so it looks like we have 2, 0, and then 1, 1. And I want to look back and make sure that fits. 2 plus 0 is 2. 1 plus 1 is 2. 2 squared minus 8, so 4 minus 8 is negative 4, plus 4 is 0, that works. 1 minus 4 is negative 3, plus 4 is 1, so they both work. Okay, so I'm going to move on, just keep on moving. Numero 10, x times y equals negative 12, and then x minus 2y plus 14 equals 0. So this time I'm going to first actually work with this equation. I'm going to do a substitution again. So xy equals negative 12, and then divide both sides by x or y. I'll divide by, what did I do in my notes? I'll do y, okay? So negative 12 over y. And then you substitute it into the unused equation. We have 12 over y minus 2y plus 14 equals 0. That is a rational equation. You want to multiply both sides to get rid of the fractions. So I will multiply by anything that's in the denominators. That looks like a y. Okay, so I'll end up with negative 12 minus 2y squared plus 14y. 0 times y is 0. Then I could divide everything by 2. Negative 6 minus y squared plus 7y equals 0. I can move everything the other side. Y squared minus 7y. This 6 is 0. And then you can factor. So I get y minus 6 and 1. Okie dokie. So looks like two solutions here. Y equals 6, and the other one y equals 1. Okay, I need the corresponding x value. X is negative 12 over 6, which is negative 2. And then x will be negative 12 over 1, which will be negative 12. Okay, so I think our solutions are then going to be negative 2, 6, and then negative 12, 1. And then I'm going to check them. Okay? So if I'm multiplying together both the coordinates, better get negative 12, right? That's that first equation, and that's true enough. The other equation, negative 2 minus 12 is negative 14 plus 14. That's 0. That works. Negative 12 minus 2 is negative 14 plus 14. They both work. Okay, so I'm going to move on. I chose these other two because they work with the addition method really well, and I just wanted to showcase the addition method. Okay, so I have these two. The first guy is actually a circle. The second guy is what they call a hyperbola. Okay, we can do column-wise addition. We'll have 2x squared equals 18. Divide by 2. X squared is 9. So x is plus or minus 3. Okay, so x is 3, or x is negative 3. So if I plug in 3, I'll have 9 plus y squared equals 13. I just picked the first equation I saw. Okay. Move the 9 to the other side. Take the square root property, plus minus root 4, which is plus or minus 2. Okay. And then the other guy, plug in negative 3. So negative 3 squared is also 9. It's the same thing. Right? Well, I'm just going to cut to the chase. I can do that. I'm the teacher. I'm allowed to do stuff like that. Okay. All right. Then I'm going to go ahead and get my ordered pairs. Looks like there's 4 of them. Okay. So the first ordered pair, 3, negative 2, and then 3, 2, and then negative 3, 2, and negative 3, negative 2. And I'm going to look back and check them. Okay. So the squares always have to equal 13. The square of the coordinates equals 13. So 9 plus 4, 9 plus 4. Every time 9 plus 4 will equal 13. Then the difference of the squares has to equal 5. 9 minus 4, 9 minus 4, 9 minus 4. They all work. Okay, so we've got 4 solutions. Okay, well, let's try one more. And we have x squared plus y squared equals 25. And then x minus 8 squared plus y squared equals 41. Okay. Okay, I think we can do addition method. Multiply. Let's multiply the first one by negative 1. Sorry. Leave the second one alone. So negative x squared plus, or rather minus, y squared equals negative 25. x minus 8 squared plus y squared equals 41. So we get x minus 8 squared minus x squared. The y squares go away. 41 minus 25. I'm going to have to do that. I can't do it in my head for some weird reason. 16. Okay. I'm going to FOIL out this dude. So I'll have x squared minus 16x plus 64 minus x squared equals 16. That'll be negative 16x. I'm going to have to subtract the 16 over. Again, I can't do that in my head for some reason. 48. So plus 48 equals 0. Then I can factor out a negative 16. X minus 3 equals 0. Looks like we have x is 3. Okay, plug that back into any equation with both variables. I'll take that guy. That'll be 9 plus y squared equals 25. I get y squared equals 16. So apparently y is plus or minus 4. So we got 3 solutions, really. 3 comma 4 and 3 comma negative 4. Oh, sorry, 2 solutions. Okay, that makes more sense. Okay, so if I square them, I get 25. 9 plus 16, 9 plus 16, both 25. X minus 8. So 3 minus 8 is negative 5. Negative 5 squared is 25 plus 16. 25 plus 16 is 41. And then for the other one, 3 minus 8 is negative 5. Squared is 25. And then, oh, it's the same thing. So they both work. Okay, there we go. Okay, so I'll throw a whole bunch of those at you. It's a good idea to check them. Okay? Make sure you're not missing any solutions. Or make sure you didn't get too many solutions. Maybe that's, and it also helps to make sure you didn't make any mistakes. Okay, so the last section, 7.5, I'm thinking of problems similar to 1 to 57 odd. So those will include sort of linear and nonlinear inequalities, and also systems of nonlinear and linear inequalities. So let's look at some of those. In particular, let's look at number 4. Sure, why not? 2x minus y is greater than 4. Okay. Okay. So I'm gonna just do. Well, first off, I note that I have to use a dashed line here, right? Because there's no line underneath the inequality. Okay, so anyways, I drop the inequality. Whoops, that should be a. I'm so used to setting it equal to 0, you know. So that should be a 4. And then I'm going to do a table. Just do a t-table, get the x and y intercepts. So when x is 0, y is negative 4. When y is 0, x must be 2. So I can do that in my head. That's easy enough. 0, 1, 2, 3, 4. 1, 2. 0, negative 4. 2, 0, dashed line. And I do test points. Okay. Okay, so usually, if possible, use the origin unless the line actually goes through the origin. So as my test point in yellow, I'll put it right here. If I plug that into the inequality and it's true, I shade the same side with the yellow dot. Otherwise, shade the other side. Okay, so I plug 0, 0 into the original inequality, this thing. Okay, so what do I get? 2 times 0 is 0 minus 0. And I'm asking, is that greater than 4? Is 0 greater than 4? No, that's a false state. Okay, so we have to shade the other direction. Turns out the other direction is what we do. Okay, so I just usually put some arrows there. I don't get carried away with the shading. It's not my deal. I don't do that. Okay, let's look at a nonlinear version of this. So be prepared for parabolas, circles, and exponentials. Okay, so parabolas like things like y equals x squared minus 1. Usually you could just do translations to get your graph, or you could do a table of values. So parabolas like that. Circles, their formulas look like this: x minus h squared plus y minus k squared equals r squared. So the center is h comma k. C for center here. Center, hk. And then the radius is r. So you have to take the square root of that number that's on the other side. So this will be the radius. Okay. And then exponentials are things like y equals 2 to the x. And everybody did a pretty good job of graphing those in the last section. So just be prepared to be able to graph anything with one of those. Let's try number 19. And well, let's try 17. Okay, this one's maybe a little more interesting. X minus 2 squared plus y plus 1 squared less than 9. Okay, so first off, that inequality tells us a dashed circle. Okay, it is a circle. Its center is at 2 comma negative 1, and its radius is not 9, it's 3. Okay, okay, so I can graph that thing. And 1, 2, negative 1 is the center. Radius is 3, 1, 2, 3. Okay, 1, 2, 3. And I just sort of go back and forth and up and down. 1, 2, 3. 1, 2, 3. Okay, it has to be dashed. And for my test value, I generally just try the center. So my test value 2, negative 1. Okay, because that will just make the stuff on the left equal to 0. So 2 minus 2 squared, 2 minus 2 is 0. 0 squared is 0. Y minus 1, negative 1 plus 1 is 0. 0 squared is 0. And then we're seeing if that's less than 9. So is that less? If that's true, so you shade the side with the test point. The test point was right in the middle this time, so that's what we shade in. Okay. Otherwise, we would shade outside the circle. Okay, so be prepared for those. Then we'll look at linear systems and nonlinear systems. Okay, so you should be able to do each. Let's try number 30. Oops, let's go back to white. Number 30. Okay. We have the system 2x minus y less than or equal to 4. And then 3x plus 2y greater than negative 6. Okay, so usually what I do is kind of work with each separately. Okay, so here 2x minus y equals 4 is the line I want to plot. I'm going to do x-intercepts. When it's in this form, it's best just to do x-intercepts. So when x is 0, y will be negative 4. Oh, that's the same line we had before, isn't it? And then when y is 0, x is 2. Okay, and we need a solid line this time. 2, 3, 4, 5. 1, 2, 3, 4, 5. Hope that's enough tick marks. 2, 3, 4, 5. 3, 4, 5. So 0, negative 4, and then 1, 2, 0. And it has to be solid. Okay. And then we could do a test point or test value. I'll use 0, 0 again. And you plug that back into the original inequality. So I'll have 2 times 0 is 0, minus 0, and we're asking is that less than or equal to 4. Okay. Our test value is at 0, 0. Let me put that in yellow. It was right here. So is 0 less than or equal to 4? And yeah, sure enough it is. Okay. So that will be a true statement. And so we shade that side with the yellow point. Okay. So I'm not going to get carried away with the shading. Let's put it at least in a different color. So I'm going to go like this. Okay. Then the other line. Let's get that guy done. 2y is greater than negative 6. So 3x plus 2y is equal to negative 6. I'm going to do my little chart again. 0, 0. When x is 0, y is negative 3. When y is 0, x is negative 2. So 0. Let's put this guy in red. Okay, so 0, negative 1, 2, 3. And then negative 2, 0. And it's dashed. Then our test value. So again, I could use that yellow point. 0, 0. Plug it back into the original inequality, right there. So 3 times 0 is 0, plus 2 times 0 is 0. 0, is that greater than negative 6? Well, yeah, it is. Then I must be shading in the direction, this direction. So where the alligator mouth closes is where we need to ultimately completely shade in. So that will just be this yellow region here. Okay. Linear systems of linear inequalities and then systems of nonlinear inequalities. So let's try, I don't know, let's try 55. Okay. So 55, let me go back to white. That'll give us a chance to graph some of these other types of equations. So I have x squared plus y squared is 16. And then I have x squared plus y squared less than 16, sorry. And then I have y greater than or equal to 2 to the x. Okay, so first the x squared plus y squared less than 16. Center is 0, 0. The radius is 4. And we could do a test value. Let's go ahead and get it graphed. I need a dashed circle. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So the dashed circle, I don't know what color to use. So I'll put it in white. Okay, test value, I'll just use 0, 0. And if you plug in 0, 0 squared plus 0 squared is 0. Is that less than 16? My test point was the center. Yes, that's true. So I'm shading inside. Okay, and then the other guy is an exponential. And we can do a little table if we need to. 2, -1, 0, 1, 2. You remember doing those? So this will be 1/4, 1/2, 1, 2, 4. Okay, so -2. Let's put this in yellow, or blue, sorry, blue. -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, and it's greater than or equal to, so it's a solid blue line. Okay, and then we want to do a test value, so come over here and TV. I can use 0, 0 again. Okay. And I plug that into the original inequality, which is 0 greater than or equal to 2 to the 0. So is 0 greater than or equal to 1? No, that's not true. So you're going to be shading above the above region. Show this region. And then the overlapping region, I'll put in red, seems to be this wedge right here. Okay. Okay, so that's the big and the small of it. Again, 25 questions long. Okay, so I'll let you go with that, and thanks for watching, and we'll see you next time.